Hello students, so welcome to the next class. We have been studying in the previous class about atoms and molecules, about atoms particularly, the structure of an atom and what is the atomic number, what is atomic mass, and then we asked a question ourselves, can atom exist independently? So the answer is no, right? Okay. Why? It has to combine with other atoms of different elements or of the same element so that it will exist in a stable form. Okay. So if two or more atoms combine together, we will get a molecule. Or if an element, two or more elements combine together we get compounds. So most of the atoms exist on Earth's crust, or most of the elements, as we say, exist on the Earth's crust in a combined state to form compounds. Okay. So what is a molecule? A molecule in general is two or more atoms that are chemically bonded together and is tightly held by attractive forces, right? So what is a molecule? A molecule in general is a group of two or more atoms chemically bonded together and it is held together by an attractive force. So a molecule can be defined as a smallest particle of an element or a compound. And molecules are capable of independent existence and it shows all the properties of that substance. So there are two cases you have studied that atoms of same elements come together to form molecules of elements, and also there when two atoms combine together we call it as diatomic. If it is there only one, then we call monoatomic. Okay, can you give me an example that you've studied in previous class about monoatomic, an example for a monoatomic molecule? Yes, argon. Yes, then helium is also an example. Iron also is found sometimes in nature. An independent existence of iron is also possible. Gold, all are metals that exist independently, and non-metals that exist independently are argon, helium, neon, krypton, etc. And then we studied about tetraatomic molecule. If there are four atoms of an element in one molecule, then it is called tetraatom. An example is phosphorus. If it is polyatomic, then you can call it as it is sulfur. C60 is also present, that is carbon atom. 60 number of carbon atoms together is formed. Okay, some disturbance outside. Okay, shall we continue? And there are molecules of elements as well as molecules of compounds, and they inside a compound elements combine in a definite ratio, right? That has been the postulate put forward by Proust. The chemical law put forward by Proust and Lavoisier. Okay, so that was about molecules of compounds, molecules of elements, and now we are going to study about a different entity So we studied about atoms, we studied about molecules, and now there is a new thing that you are going to study, ion. What is this ion? Ion. Okay, I-O-N. Sometimes a compound, for example, we are taking NaCl. So in the periodic table, I said that sodium part on the left hand side of the periodic table, it contains mostly metals, and right side contains non-metals. In most of the cases, in a compound, it is a combination of a metal and a non-metal. Okay, how does it combine? That is what we need to know. So what happens here, or what makes this single atom of sodium and a chlorine atom to come together? So there are some theories behind it. So they all, what happened, these independent atoms acquire a charge on it. How does it acquire charge? By gaining an electron or losing an electron. So in the case of sodium, sodium gives out an electron. Sodium gives out an electron, and so when one electron is given out, and for example, sodium contains 11 electrons and 11 protons. So in this case, 11, the charge of the 11 electrons will be cancelled by the charge of protons. But if one electron is given out, the majority, there will be one positive charge will be more, and that more positive charge makes the sodium atom a positively charged atom, and that is called a charged atoms are called ions. How does an atom become charged? Atoms gain electrons, or in the case of sodium, here it loses an electron to form a charged atom. Here it is a, and charged atoms are called ions. So since it is a positively charged ions, they are called cat. T I have written as a positive sign, cat ion. Okay, that is what happens for sodium. So what happens for chlorine? What happens to chlorine? Chlorine gains an electron, plus one electron to chlorine. So the majority of in the chlorine atom, the electrons will be more. So chlorine attains a negative charge. So one atom in NaCl is a negative charge. Another atom is a positive charge. Another atom which is on the non-metal side gains a negative charge, and the atom with the negative charge are called anions. Okay. So what happens here? What happens when like charges come together? It will repel. What happens when unlike charge come together? It will attract each other, and there will be a force of attraction which attracts sodium to chlorine. Okay. So then it comes together to form a compound. So what is an ion? Means a compound composed of metals and non-metals usually contains charged species in it. The charged species are known as ions. How does it form? Ions may consist of single charged atom or a group of charged atoms that have a net charge on them. So it can be a single atom, as in the case of NaCl. There's only one atom, Na positive, and another atom is Cl negative. Sometimes in the case of, if you are taking CuSO4, this is another one. This is the metallic part. This is the non-metallic part. Here in non-metallic part, if you take the non-metallic part, there is a sulfur, there is a carbon, there are group of atoms are there, okay, carbon, and oxygen. So sulfur is there, oxygen is there are 4 oxygens present. So total there are 5 atoms coming together with a net charge of -2, and here the net charge on the copper is +2, okay. So ions may exist as single charged, as you have seen here, or as a group of atom having a net charge on them. So then we have also studied ions can be positively charged. If it is give out its electrons, then we get a positive charge ion. And there is a negative charge ion which is kept, it is called anion. Positive charge is called cation. And so the example of sodium chloride is given here. Sodium chloride, in a sodium chloride compound, the constituent particles are positively charged sodium ion and negatively charged what ion? Chloride. Chlorine, we say that chloride ions. Okay. And in some cases, as we have seen over here, SO4, the group of atoms carrying a charge is called a polyatomic. Polyatomic, number of atoms are more, so they are called as polyatomic ions. Okay, so now we shall learn more about how a formation ions are formed in certain elements. Okay, now in table 3.5, as you can see, what is given over there? Ionic compounds are given. What is the specialty of ionic compounds? Inside ionic compounds, the atoms are present in its charge state, or somewhat there is charge, and a positive charge gets attracted to a negative charge and they combine together. Ions combine together to form an ionic compound. So in this case, first is calcium oxide. Let's see what are the constituent elements present in this ionic compound. So calcium oxide consists of what are elements? There is calcium and oxygen. Ca, we'll write it the symbols, and O is present. And we can also, if you look at the ratios, we can find out that it is in the ratio of 5:2. Okay. And similarly, there is magnesium sulfide given. Magnesium sulfide, from the name itself we can say that there is magnesium in it and sulfur in it. That is also combined in a definite proportion, 3:4. So if you know the atomic mass of these elements, atomic mass of oxygen, and we will be able to find out the ratio by mass with which it combines. So these are about ions. So what are ions? Ions are charged atoms, charged species. It contains single charged atom or a group of atoms which has a net charge on it. Mostly in the case of ionic charge compounds, two charges or unlike charges come together to form an ionic compound. So in the case of NaCl, Na positive ion is present, Cl minus ion is present. How is it formed? If an atom loses one electrons, its net charge will be one electron is one less in the case of calcium, sodium. So it becomes positive side. Okay, and if an atom gains electrons, then the net charge, proton's charge will be less in that case, and thus it will attain a negative charge. Okay, now let's see how we are going to write down the chemical formula. Okay, let's read what it is written. So, chemical formula of compounds. So, here we have seen a lot of compounds, calcium oxide, magnesium sulfide. So, while I was writing, I took a lot of time in writing. Okay, and we also have learned about symbols that we have used. Again, compounds are also written in its symbolic form, and that is called as the chemical formula or chemical formula. And how are we going to write this chemical formula is the question. So chemical formula of a compound is a symbolic. What is a chemical formula? Chemical formula of a compound is a symbolic representation of its composition. So here this is a composition are given over here, and according to this, we are going to find out what is the chemical formula. And by looking just at the chemical formula, we will get an idea of the proportion at which these elements have come together. For example, if I say Na2O, NaCl, both we are taking. Here what will be the ratio of this ratio of the atoms present? So it contains two atoms of sodium and one atom of oxygen. That is the ratio. And according to the mass, if you know the mass of oxygen, Na, it is 23, and there are two Na atoms, then it will become 46. And what about oxygen? Oxygen is 16. So 46 is the 16. And if you reduce it, if you bring it into a smaller, it can become 23 is to 8. And we'll not able to. This is the simplest form that we got. Okay. And by simply looking at the chemical formula, Na2O, it's a chemical formula, we can find out at which ratio by mass it is being combined together. Okay, so chemical formula of different components can be written very easily if you learn about the symbols and combining capacity of elements. Now there is a new word called combining capacity, and what is that all about? Okay, so let's see what combining capacity is. I'm going to rub this portion. So if you know what is the rule said over there, if you know about the symbols, okay, you mostly know about all the symbols, and the combining capacity is the next term that is given there, then you will be able to find out the chemical formula. Okay, so what is this combining power? The power with which, so we have already learned that two atoms combine together to form compounds. So elements plus another element gives a compound. There should be a reason behind it, and that reason is that it needs to be dependent so that it can be stable, and each and every atom has some kind of combining capacity or combining power. What is it? So, a combining power or capacity of an element is known as its valency. And so now what is valency? Valency can be used to find out how many atoms of an element will combine with the atoms of another element to form a chemical compound. So how many atoms of a particular element will be combining with the, so valency, it is not the number of atoms, it is actually valency will tell us, valency is something with that will tell us how many atoms of an element will combine with the atoms of another element to form a chemical compound. And valency of an atom of an element can be thought as the hands or arms of an atom. Actually, about this valency, you will be studying in the next chapter. But here they are making you a little bit confused. I don't know why. So, valency is that hand that we give. If you are happy, if you want to hold somebody, we will give our one hand, right? We will give our hand. And that is my valency, the combining capacity or the need or the wish or something, that power with which I want to bond with something. If you are really so happy, we may give both hands. Some elements give both the hands. Some has three hands to be given out. Okay, or something like that. If you say about octopus, how many hands has it got? It has got 8 hands. In the case of octopus, it will be giving its 8 hands. If other insects, there are 6 hands or legs, they will be giving out its all the 6 hands or legs for combining. Okay, similarly, this valency of an atom, if there is an atom, if you say sodium atom, it has only one hand or one valency to which it can get combined to. Only one is given for combining with another atom. Okay. So human beings have 2 arms and octopus has got 8 arms. If one octopus has to catch hold of few people in such a manner, and the 8 arms of octopus and both hands of the human beings are locked. For example, if you have an octopus has 8 hands, so how many hands human beings have? Two. So 1, 2, 3, 4. It will be holding, giving its hands to how many? 4 people altogether. And this is called the combining. You can say that the combining capacity of octopus is 8 and combining capacity of the human beings are 2. So human beings have 2 arms and octopus has 8 arms. If one octopus has to catch hold of a few number of people in such a manner that all 8 arms of the octopus and both arms of all the human are locked, how many humans do you think the octopus can hold? Yes, it is 4 indicates the number. So, valencies are something, or valencies are something which is used, does not anything that we say, it is just used to find out how many atoms of an element will combine with the atoms of another element to form a chemical compound. This can be explained in a different way, but since you haven't studied about what actually valency is, I'm sticking to what the text says. So actually valency is the combining capacity of each and every atom present in that element, and that says or how it is going to combine with other atoms. Okay, so valencies of some of the common ions are given below. These you need to by heart it, but I can tell you some tips and tricks, and for that I have to explain a little more about it. So you have seen that the sodium and potassium belong to somewhere here in the periodic table group 1. Here, what actually valency is, it is the number of electrons that are readily available for a chemical bonding. So for a bonding to happen, electrons had to be lost or electrons had to be gained, or electrons has to be available, readily available for a bond to happen, and that is actually valency. So in the case of potassium, sodium, silver and copper 1, the valencies are symbols of ions are given here first. It is Na positive, K positive, Ag positive and Cu positive. Na positive means what? The sodium atom has given out is one electron to form a positive ion. And what is this all about? K positive potassium ion atom has also given out one electron to become K plus. Okay. So these are the ions. What about magnesium? So silver also it is Ag plus, that means silver gave one electron. Copper 1 is also Cu plus. What about magnesium? Magnesium belongs to second group of that periodic table and it has got two electrons in its shell, outermost shell to give out. Okay, so it gives out two electrons to form Mg2 plus. Calcium also gives out two electrons. Is it clear to you? Calcium also gives out two electrons to form Ca2 plus. Zinc, again it has got two electrons to give it out for the chemical bonding to happen, so it has to zinc 2 plus. So you need to study all this. If you study this, then you will get to know what is the valency and then we will be able to write down the chemical equation. So ion Fe2 plus ion 2. Some of the atoms have variable valencies that we will learn. Okay, then copper 2 is Cu2 plus. Aluminium has got 3 valency. So it gives 3 electrons out. So it gains Al3 plus cation, Fe3 plus. Then here there are non-metallic elements. Hydrogen is H plus. Hydrogen can also gain an electron to become H minus. Chlorine gains an electron to become Cl minus. Bromine Br minus. Iodine I minus. Only one is there. Oxide is O2 minus. Sulfide is S2 minus. Nitride is N. Nitrogen has got the 3 electrons. Nitrogen has got 5 and it needs 3 more electrons. It takes in 3 more electrons to form N3 minus. Now, in the last table, we have given the polyatomic ions. Okay. So, here in the case of ammonium, you have learned about ammonium hydroxide in acid, bases and salts, right? Also about HNO3, right? Na2CO3, right? All these things you have already learned, right? This is a weak base, this is a strong acid, this is a salt which has called sodium carbonate and CuSO4, and this part they are polyatomic ions. If they split into two, we will get Na and NH4 positive, OH minus, NO3 minus, HCO3 minus, CO3 2 minus, SO3 2 minus. These you need to by heart it. Sulfide ions also SO4 2 minus. So net charge on the sulfide ion is minus. It doesn't have, it has more electrons in it. Then phosphate ions PO4 3 minus. So these are the names and symbols of some ions. Okay. So if you know all these things, then it will be easier. So you need to learn about it. Okay. So if you know the symbols and the combining capacity of electrons, it is, or if the ions, it will be easier for finding out the chemical formula. Okay, so rules that you know, that you should know or you should follow while writing a chemical formula is given here. So the valencies or charges of an ion must be balanced. Okay, and when a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. For example, calcium oxide. So metal is calcium, oxygen is the non-metal, it is written later. Sodium chloride. Sodium is the metal, fluorine is the non-metal. Iron sulfide. Iron is the metal, sulfide is the non-metal. Another one, copper oxide. Copper and oxygen is present. Copper is the metal, oxygen is the non-metal. So similarly, it is written. Whereas here you can see that calcium, sodium, iron and copper are metals and are written on the left side. And again, the compounds formed with polyatom, the number of ions present in the compounds is indicated by an enclosed formula. It should be written in brackets. The number of ions outside the bracket. For example, MgOH twice. In case of number of polyatomic, this one, the bracket is not required in the case of NaOH. These laws, we'll write it down and find it out how it works. Okay, then you will get an idea how to write. So formula of simple compounds. Okay, how will you write the formula of HCl? So H is there, Cl minus is there. As per the valency, valency of hydrogen is 1, valency of chlorine is also 1. Then you interchange it, you get HCl. So simplest compound are made up of two different elements and are called as binary compounds. Valencies of ions are given in 3.6. You can use to write the formula using it. While writing the chemical formula for the, we write the constituent elements and their valencies as shown below. Okay, valency of, we have seen it is H plus and this is minus. So valency is 1 and 1. And then we cross over the valency. Valency of this hydrogen is given to chlorine and this is given over here. Okay. Again, another one is hydrogen sulfide. Do you want to look what the valency of sulfide is? It is S2 minus. Hydrogen is H plus. So 1 and 2. Then we are crossing over the valencies and we will get H2S. S is the symbol for sulfide. So what is said? In the first case, the valency or charges on the ions must be balanced. Okay. So here what happens is, for one sulfide atom, we need 2 hydrogen. That is how it is balanced. Okay. Then next one is carbon tetrachloride. CCl. So chlorine's valency is 1. Carbon's valency is 4. and you can write as CCl4. For magnesium chloride, we write the symbol of the cation Mg, 2 plus first, followed by Cl minus. And this Mg's valency is 2, chlorine's valency is 1. We cross it over, we will get MgCl2. Magnesium fluoride is written like that. Okay, so thus magnesium fluoride, there are 2 electrons for each. The positive and negative charge must be balanced each other, and overall structure should get a neutral charge. Note that the formula and charges on the electrons are not indicated there. So when you write down, we are not going to write it as +1 and -2 on the chemical formula. You just write down the number of atoms present according to the valency, and we'll write it down. So there are the valency of 2 elements are the same. You may arrive at a conclusion if the valencies here in the case of calcium or calcium oxide, calcium has got the valency 2 and oxygen also 2. Calcium is 2 plus 2 minus. If you cross over it, we will get Ca2. Or if something like this comes, we have to write it into, reduce it into its simplest formula. Simplify it and write it as calcium oxide. Okay, next one. Write the formula of sodium nitrate. Sodium we have learned it is +1. Nitrate from the equation it is -1. You will write it as NaNO3. And if it is calcium hydroxide, how will you write this down? Calcium is 2. And OH minus is 1. So when you cross over, you will get like this. You know calcium is Ca, OH is hydroxide is OH. So you're going to give this 2, not to one hydrogen, but the whole ion. Whole polyatomic ion gets this charge as 2 or whole into 2. So you need to write it inside brackets. Okay. So that was about the chemical formula of calcium hydroxide. We use brackets when we have 2 or more same ions in the same formula. So to write down the symbol of a molecule, we need to know what are the constituent elements present in it. If it is, you are saying an example of hydrogen chloride, we know that there is hydrogen present and fluorine present. We need to write down its names and its symbols. Then what we need to know? Then we need to know the valency or combining capacity, which is in turn given by the valency. And valency lets us know how many atoms of each are present in a compound. And valencies are written down for each. And valency, you have given a table over there. You need to study the valency of the ions that are present and then write it down, cross it over, and we will get the formula for the particular element. It is valency is less like something giving out a helping hand so that they can hold to it. Okay. In the next chapter, we will see what valency is actually is. Now, we just need to know that it is something that an atom gives out so that it can combine with the other atom. Okay, so here there are some questions given. Let's see what it is and then let's wind up the class for today. So write down the formula for taking aluminum chloride, the second question. Since it is your first time that you are studying about the combining capacity or valency, you can check the table and find out what is the valency. First tell me what is the symbol of aluminum? Al. and symbol of chlorine is Cl. Now find out what is the valency. Aluminium forms 3 plus ions. So valency is 3. Okay. And chlorine Cl minus it is given, so valency is 1. We are crossing over the valencies and we are getting AlCl3 as its formula. We will not be writing plus minus or anything. No charges are written when you are writing the chemical formula. Okay, next let's see what is sodium sulfide. Sodium Na, sulfide is sulfur, and valency of sodium is 1, valency of sulfur. Yeah, you can check your text, it is 2. Crossing it over, we get Na2. Yes. Okay. So, from this portion, another one is, can you tell me what was that question asked? Write down the names of the compounds. That is easy, right? It is very easy. You need to know the names of that ions. So Al2, we're going to put a bracket. SO4 thrice. What is the name? This is aluminium. This is what ion? Sulfate ion. So the name is aluminium sulfate. And what about this CaCl2? Calcium chloride. K2SO4, this potassium and sulfate, so potassium sulfate. KNO3, this is nitrate ion with potassium, so potassium nitrate. Okay, so these are the things. One more question. If I ask how many atoms are present in this ion, what will you tell? PO4. 1 phosphorus and 4 oxygen. So 5 atoms. So this is a polyatomic example of a polyatomic ion. Okay. So now we will wind up the class for today. Hope you had a informative session here. So, see you. Bye.